This video will be on physics, motion in one dimension, as well as the introduction to physics. So, why do we learn physics? Well, the goal is to understand the physical world. Okay. In physics, we also have a lot of math usage as well, especially calculus usage. But anyway, besides the basics of what physics actually is, we should go to the vector and scalar quantities first. So I wrote vector and scalar here. Now we should know what a vector is. A vector has magnitude, which is basically the measurement, and direction. So not only is it just saying 50 miles per hour or 50 this, it's saying also going east or going in the x positive direction or going in the x negative direction. Okay, so we also have scalars, which is just all they have is magnitude. They're like mass. If you weighed something and it said how many grams it was, it would be mass, right? It would just give you the reading and temperature. It would just give you the reading, like speed. They don't tell you which direction you're going when you have speed, right? A vector would be velocity, is an essential one. Acceleration. And then we have displacement. So anyway, to continue, we also have study of dynamics, and kinematics. I do apologize for the penmanship. It is very difficult to use one's mouse to write. So dynamics, it's the study of motion that deals with concepts such as force and mass. So we have, I'm just going to use capital F, and mass. It's an overall study, and kinematics is very different. It just describes motion without regard to its causes. So we don't care about the causes. So don't care. We don't care about causes. We don't care about what acted upon it. We're not gonna care about the force, the gravity, any of it. So we're gonna start right now with displacement. Okay, displacement. Now, displacement, it's basically the vector quantity of the scalar quantity called distance, although they're very different, and I will demonstrate that. It's just a way of thinking about it. It involves a frame of reference, so we have the frame of reference. I'm going to abbreviate frame of reference, which we have our xy coordinates, or an x direction, or some sort of line that it's going in. So basically, we have this is the formula equation. F minus xi. Xf just means the final, and xi means the initial, right? And delta x is change in x, right? And that's what we're trying to find, the change in x displacement. It's usually given in meters. Positive answer indicates in the positive direction, like negative answer is in the negative direction. It's not needed to put something like an arrow above it in this topic. Like we usually have velocity as the arrow and acceleration as the arrow, but it's not needed simply because this is one dimension. So how many ways can it go? Well, only two ways, so there's no reason to put an arrow. So anyway, let's use an example. I'm going to rewrite the equation. Then x is equal to xf minus xi. So anyway, if we have a point from A to B, if we have a point A to B, where the initial is equal to 30, and the final is equal to 50. Well, we apply it. 50 minus 30 equals positive 20. Since it's usually given in meters, let's write meters. So that's in a positive direction, right? But then again, displacement is not the same as distance. An example. Okay, so if I toss a ball in the air, the distance would be twice the maximum height, right? But the displacement is 0. Okay, so that basically gives us the real reason why they're quite different. And that example should demonstrate that. So, velocity. Let's start with that next. Velocity can be given as this or this v bar. We're just going to use v bar because we don't need the arrow if it's just one dimension. Like I said earlier, it has to be a vector. Why does it have to be a vector? Well, think about it. If you wish to travel, let's say 20 miles to a nearby place, well, how would you get there just by 20 miles? You would also have to have the proper direction, correct? You need to get there with the proper direction in order to actually get there, right? So that's why it's a vector. We're going to go through average speed as well, just to differentiate, and not like calculus differentiating. So anyway, well, average speed is given as basically length, or you can say path length over time, or elapsed time. And the symbol could be v equals v over t. And this v is not to be confused with that v. They're very different. So, like, let's say if we have something about John and Jack run over a distance of 5.0 km. 0 km. Right? And then, let's see, John finishes, okay, and his total time is 2 hours. Well, what's the average speed? I'll just put, well, 0.00 over 2.00, right? Give over h, which gives us 2.5 per hour, right? Let's basically have to solve that. And now we'll go into the average velocity given by v bar. Change in x or change in t, which basically equals, this looks very similar to a slope sort of formula in a way, but not exactly the same. Xi over, well, tf minus ti. Now the I and f, initial and final, right? It's given in meters per second, so m per second. It can be positive or negative, whereas only average speed is only positive, right? So let's use an example. If I have 50 minus 30 over, let's just say like 10 seconds minus 0 seconds, well, that equals 2.2, right? Meters per second. And that's how you basically would apply it. Whenever you're given that information, just plug it in, solve for that. We also have a thing called instantaneous velocity. Now, that's where you go into calculus. Let's go with this. In the calculus videos, I showed how to find the instantaneous velocity, and it looked a little like take the limit as h approaches 0. Of something like, if I had, I don't remember the numbers exactly, but I had something like 16, like x plus h squared minus 3 squared, or something like this, over h, right? And this is how it usually goes, right? It's kind of like a derivative, same thing. So you're trying to find the slope of the tangent curve, and that's how you find the instantaneous velocity. Instead of going through the secant line, you're going through the tangent line. At that instant, well, at that instant, that basically gives you that velocity at that instant. And that's why calculus is fundamental to physics as well. Um, in the next video, I wish to go over acceleration and finish up the motion in one dimension. Right now, I will discuss a little bit more about physics. Physics is important to our daily lives as well, and it's also fundamental that you learn calculus and learn some sort of math before you go into physics, as you have vectors sort of things, you have trigonometry. The key to physics is not memorization. The key to many things which have equations is more of deriving equations and finding logical answers to solutions, because how can you memorize 1,000 equations? You can't. Okay, so I will show you an example of how to derive an equation actually from chemistry, in which I have something like P1 or T1 equals P2. This is like the ideal gas law, right? The way to derive this is, well, if they give me something constant, then I can just exit out on one of these things. So if like temperature is constant, exit out the temperature, and then I'll just simply have P1 V1 equals P2 V2. And that gives me that equation, right? And that's probably one of the laws. I do not know which name. Constant temperature is probably Boyle's law. In other words, that's how you would find it. So that is basically the importance of math upon physics. And not only that, every situation that you're presented in physics typically consists of doing some mathematical calculation to understand the world around us. Gravity is also a part of physics, and Newton's laws of motions, which I will go into as well in the next video. If you have any questions, please feel free to ask. If you wish to subscribe. That's basically it.